for everybody, we're looking at number 7. We skipped number 6 for today because I just don't feel like doing it yet. For 7, prove the diagonals bisect each other. Any thoughts on what to do? What does bisect mean? Means that they cross, but they cross somewhere special. They cut in half. They cut something in half. So if they do that, then we want to make sure, essentially what we're finding out is if the diagonals cross each other in half or if their midpoints are the same. So I've got a list of points right here. So A is at -2, -3. B is at 0, 1. C is at 6, 7. And D is at 4, 3. First, let's give it a draw. Let's draw it out and let's see where the diagonals are. So I've got a little axis right here, coordinate plane. A is at -2, 1, 2, -3, 1, 2, 3, somewhere down here. It's just a sketch. It doesn't have to be exact. I just want an idea of what's going on. B is at 0, 1, so I don't go left or right any. I just go up 1. That's where B is. C is at 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And D is at 4, 3. 1, 2, 3, 4. 1, 2, 3. Ooh, this is an ugly shape. My scale might not be great, but I've got what looks like some kind of 4-sided figure, a quadrilateral, if you remember from geometry. We want to know if it's diagonals bisect. So which 2 points will be diagonal each other that I'm going to connect? Hold on there. AC, BD. And that's half the battle too. If we did not have, if we didn't label it, then we would have had them in the wrong space necessarily. This is not to scale, so I'm going to look at it and not know necessarily if it's midpoints or not. We just learned the midpoint formula, so let's do that. Let's find the midpoints. And let's play smarter, not harder. So girls, let's find the AC midpoint. Boys, you find the BD midpoint. We don't need to keep practicing midpoint. Most of you know it already. AC, BD, just practice one of them. Once you get it, check with a friend, see if they also got it. Once you've checked with a friend, check with the board, see if I also got it. Did you get your midpoints P.2 too? Yeah, everybody? Are those midpoints the same? Yeah, that means the midpoint here, that means that this distance is the same as that, and this distance is the same as that. I know it's been a while since we've seen markings like this. It's been a while since we've been in geometry class, but this shows me that it does bisect them. So bisects, cuts in half. We want to check if midpoints are the same. So if I ask you something like this in the future, do the diagonals bisect each other? Check their midpoints. If they're the same, yes. And so in this case, I'm going to write yes, they are. All right, now we're going to do some circle practice. Circle practice. You guys do circles in algebra 2? Yeah? We're going to first write the equation of the circle. The first one says C 0, 0. What does that mean? The center. Center. Center is that, radius is this. Does anyone remember the general form of a circle? That's my general equation. Oops. There you guys go on Zoom. Anybody? No? All right, general form is x minus h squared plus y minus k squared equals r squared. Now we have to know what those mean, right? X and y are variables. They stay the same. Don't move them. Keep them there. H and k refer to the center. So the point that's the center is positive h, positive k. So whatever the center is, you need to switch the sign to put it into the parentheses. Switch sign, switch sign. R is squared, so whatever the radius is, you either need to square it, or if you're taking it backwards, we're going to do the square root of it. Okay? In this case, my center is 0, 0. Do I physically need to write 0 and 0 in there? No, that's a waste of time, waste of ink. X squared plus y squared equals 3 squared, which is 9. All right, well, I write the other two on the board. Can you try them on your own?
Wait, how'd you get 9?
3 squared.
Oh.
All right, did you guys do B and C yet? Can we do it together? All right. So my center is my H and my K. H, K. My radius is my R. When I plug it in, I've got 8x minus H. H is 5, so I'm going to keep it minus. X minus 5 squared plus y minus K is negative 4, so I'm going to make that a positive, plus 4 squared equals radius squared. 6 squared is 36.
That's it?
That's it.
Oh, okay.
I don't need you to do anything else. We will do more later, but right now this is it. Same idea for the last one. I've got H, I have K, I have R. Anyone think they know? We all tired from lunch? Allie?
X squared plus 4 minus, or y minus 4 squared equals 5.
Yes, yes, yes. Everything there is right. I don't need to put any parentheses with X because H is 0. I've made it minus, switch the sign, and then I square root 4. The square of a square root is, oh, sorry, I squared this, the radius. That becomes 5. All right, cool. Now we're going backwards. If you haven't gotten the hint, that's kind of what we're doing. Go forwards, go backwards, go in all the different directions. Now we're going to identify the center and the radius from an equation. This is, oh, whoa, whoa. This there's less math. He made it in the recycling bin. All right. Identify my center. Those are the two numbers that are on the left side of the equation. My radius is what's on the right side. What numbers are going to pull out? What's going to be in my center? Positive 2 or negative 2? Positive 3 or negative 3? Remember to switch your signs. What's my radius?
4.
Awesome. Can you do the rest while I put them on the board? All right, we're probably done. What's my center on B? -5, 0. What's my radius?
Square root of 7.
Square root of 7. What's my center on C? 0, 0. What's my radius? Square root of 10. Very good. You guys couldn't be tricked. All right, how are we doing? Good so far? Okay, we're moving on to 10. It says, write using the absolute value. I don't know if this was familiar to me until I taught it, so let's go over it together. In my black pen so everyone can see online. Number 10 says write using absolute value. And letter A says the distance between X and 3 is 8. Okay, we're going to break that down. The distance between, absolute value refers to distance, okay? If I have like a number line and I'm looking at 2 to 5, right? What's my distance from 2 to 5? 1, 2, 3, 3, 4, 5. 3 little spots. If I went backwards, what's the distance? 3. 1, 2, 3. When we subtract these numbers, if I do 5 minus 2, we know that that's positive 3. But if I go the other way and do 2 minus 5, we know that that value is negative 3. However, we're talking about distance, and distance doesn't change. Can you run negative 3 miles? No. You can't drive negative 50 miles to your friend's house. You can't do that. So distance is always positive, and so we think of these as absolute values. So if I say the distance between, that in your head should go off, ding, 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 absolute value. Distance is absolute value. So distance between X and 3, it doesn't matter which one you do first because I'm minusing them. And then I'm going to do the absolute value, so it doesn't matter if you do X minus 3 or 3 minus X. And then is, remember back in Algebra 1? Is like a very common word for what? Equals 8. That's it. I don't even want you to solve this. I just want you to write that. So the next one says the distance between X and negative 2 is more than 7. X and negative 2, we would do X minus negative 2. It says distance, so we're going to do absolute value. And then it says is more than 7. This is greater than 7. You can even simplify this to just be one big plus sign instead of 2 ugly minus signs. That works. That's it. That's all we're doing. Can you try and think through C and D by yourself or with a neighbor? See if you can do those by yourself. All right, what do we think for C?
4 minus X in the absolute value.
Awesome.
Equals 12.
Perfect. What about D?
X minus 5 absolute value is less than or equal to 3.
Is less than or equal to, let's talk about that. It says
more than.
is no more than 3.
So
Can it be 3?
No.
No.
It cannot.
It can be 3, but
Yeah,
it
it
can't
can.
be more than.
It cannot be more than. So it can equal 3. It cannot be any more than. Cool. Just got this firework. All right, flip it over. And that. I know. I can tell. I'm losing a lot of you guys. I was trying to think of a game, but I don't have a game. Let me think of a game for tomorrow. We need a little brain break, but I don't have one off the top of my head.
Heads up, 7 up.
I need one that there's no touches.
Let's just play tap out of that.
Let's do this. Let's do number 12. And maybe we'll do one of number 11, but we're not going to finish this tonight. So we will not finish this. So P2 is not necessarily assigned yet. You have a lot of keys to start working on it, but I'm not assigning it. It's not due on Friday yet because we are not finishing this completely. Okay? All right, 12. I skipped 11. M is the midpoint of B of AB. Find B. M is midpoint. Find B. So letter A says M is 6, 2, and A is 5, 1. What do I need to know to do this? What formula do I need to know that we've learned today? Midpoint. No, we learned a midpoint just like this. We did x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now that is equal to a midpoint that is an x and a y. We don't have either x1 and y1 or x2 and y2. We don't have one of the points inside here, but we do have this point over here. Anyone remember this from geometry? Because we for sure did this in geometry. So we'll call this x1, y1, and then this is just our normal x, y. So 6, 2 is going to equal my midpoint formula. Is that it?
Yeah.
Oh, I really thought we had more time. Let me plug this in. 2. We have x1, 5, but we don't have x2, so that's where your little guy goes. We have 1, but we don't have y2, so that's where your little variable goes. The way we finish solving it is by setting this 6 equal to the x value over here. The x's have to equal each other. 6 equals 5 plus x2 divided by 2. In a separate equation, that's going to give us our y. 2 is equal to 1 plus y2 over 2. I'm going to just kind of pause there. Try it tonight. We're going to catch up here tomorrow. I'm going to say goodbye to Mason and Whitley. Bye, guys.